UNI-TEAS 2026. I am Sneha Rathod, and it's an absolute pleasure to moderate today's online session. This prestigious conference is being organized by Shree Universe College, Apex University, and Panipat Institute of Engineering and Technology, managed by KK Consultancy Services India and supported by University of Rajasthan, ACM Jaipur Chapter, All India Council for Technical Education, and Computer Society of India, Jaipur Chapter. This year, we received an overwhelming response with over 300 paper submissions and 300 paper submissions from across the globe. After filtering AI-generated and plagiarized content and a rigorous peer review process, by our expert panel, only the top 80 papers were selected for presentation. Based on their performance and the recommendations of our session chairs, their selected papers will be published by Springer Nature. The first half of the day one, on 16th February 2026, we had an incredible series of keynotes, paper presentations, award ceremony, and discussions that truly embodied the spirit of innovation and inclusivity offline in Jaipur. As we step into the latter half of the day two, we carry forward that same enthusiasm, ready to dive deeper into thought-provoking sessions and interactive presentation that will continue to shape the future of intelligent system and digital security. Now, with great honor, I am pleased to introduce our esteemed session chair for this segment. First, Dr. Gaurav Kumawat. He is an associate professor at Manipal University, Jaipur, and we are privileged to have him guide today's technical deliberations. Thank you, sir, for joining us today.
Thank you. Thank you, Sam.
Next, I warmly welcome Dr. Dhiren Patel. He is a professor at Gujarat University, Ahmedabad, and his insights will certainly enrich today's session. Thank you, sir. Now, I would also like to welcome Dr. Priyanka Mishra, ma'am. She is a professor at Poornima University, Jaipur. Her guidance will add immense value to our discussions today. Thank you, ma'am, for joining us. On behalf of UNI-TEAS 2026, I extend a heartfelt welcome to all our session chairs. We are truly honored by your presence. Before we proceed further, I would like to share a few important instructions for all the paper presenters to ensure a smooth and timely session. Yes, ma'am, you want... Each presenter has 10 minutes to present. Please stay within the time limit. Briefly cover your research context, objectives, methodology, key findings, and conclusion. A short Q&A may follow your talk of 1 to 2 minutes. Keep responses brief and focused. Keep your mic muted when not speaking. Stay for the full session to support the fellow presenters. Now, with the kind permission of our session chair, we shall now begin with the paper presentations. I would like to invite our first presenter for the day, presenting the paper titled Machine Learning Assisted Techniques for Enhancing Interpretability in Models under the code 427. I request Mr. Amit Nagarkoti to kindly take the virtual stage and begin their presentation. Over to you. Are you there, Amit sir? I think we should begin with the paper 2 presentations. He's absent. So I would like to invite our second presenter for the day, presenting the paper Serverless Web Applications Using Cloud Computing under the code 428. I request Mr. Ambati Mallikarjun to kindly take the virtual stage and begin their presentation. Over to you.
Good afternoon, ma'am. Good afternoon to Dhiren Patel, sir, Priyanka Mishra, ma'am, and everyone. Our project title is serverless web application using cloud computing. The introduction, I would like to say that the restaurant industry is undergoing rapid digital transformation, requiring scalable, intelligent, and automated management systems to
Yeah,
overcome the
um,
limitations
I
of.
just want to interrupt you in between. Will you not share your screen? We cannot
Yeah,
see
ma'am.
your presentation.
Yeah, ma'am. Okay, ma'am. Yeah. Am I visible, ma'am?
You are visible, but your presentation is not visible.
Ah, okay, ma'am. Okay. Okay, ma'am. One second. Okay, ma'am.
No, it's not visible. Now it's visible.
One second, ma'am. Ma'am, is it visible?
Yes, you may start with the presentation.
One second, ma'am. Yeah. Ma'am, it is visible.
No,
Ma'am,
it is
ma'am.
not visible.
Sorry, it is not visible.
Okay, one second, ma'am. I would like to share my PPT. Is it visible, ma'am?
Yes.
PPT. Ma'am, PPT visible?
Yes, it is visible now.
Yeah, PPT. Yeah, my title is serverless web application using
Let's go
cloud
to
computing.
slideshow. Press F5 for the slideshow.
Slideshow. Okay. Yeah. Okay. Okay, sir.
Yeah.
Serverless web application using cloud computing. Myself, Ambati Mallikarjun, studying BTech final year, Institute of Aeronautical Engineering College. Introduction. The restaurant and food service industry is experiencing rapid digital transformation. It's requiring scalable, intelligent, and automated management systems. Traditional monolithic structure has lacks flexibility, scalability, and cost efficiency. To overcome these limitations, we came up with idea DineSync, a cloud-native serverless restaurant management platform. It is built by using microservices and AWS infrastructure. Problem statement is existing restaurant management systems suffer from poor scalability, difficulty maintenance, and slow deployment, limiting limited fault isolation and high infrastructure overhead. These challenges restrict performance, reliability, and business growth in modern cloud environments. And proposed system is the system is built as microservices based application which has front end, back end, and infrastructure. Front end is designed with responsive web interface using HTML, CSS, and JavaScript exposed via application load balancer. And back end is developed with independent microservices. We used order, cook, and billing services deployed as Docker containers. An infrastructure layer with Amazon ECS with AWS Fagret, Amazon ECR for image storage, secured using VPC, IAM, and monitored through CloudWatch. The main objective is to design and implement scalable native system that includes microservices architecture, ensures high scalability, high availability, optimizes infrastructure cost, and deploys server containers using AWS Fagret. And the methodology we used is design the system using microservice architecture with order, cooking, billing, and front end, and ensured security with IAM and VPC, monitored platform with CloudWatch and its performance, validated the response time, load balancing, and reliability. Recommendation system and performance optimization. The system supports further ML-based food recommendation by analyzing customer preferences. Predictive demand forecasting can optimize inventory. Auto scaling ensure dynamic resource allocation and reduces the latencies via internet AWS networking. And the results of these projects are front-end response time is 180 ms, order service response time is 110, cook service response time is 120, billing service response time is 115, and it also has stable performance under light traffic conditions. These results validate the scalability efficiency of the serverless microservices architecture. I would like to conclude that Dancing successfully demonstrate that serverless microservices architecture using Docker and AWS improves scalability, maintainability, deployment efficiency, and cost optimization compared to monolithic systems. Future scope of this project is CI/CD pipeline integration, enhanced API security, AI-driven personalized recommendation engine or systems. Thank you. Ma'am?
Talked about the, the accuracy which you got.
Ma'am, it is application-based data, ma'am.
Yeah, you developed a front end, okay,
Yeah,
and the database which you have been talking about is,
ma'am. We use application data, ma'am. Customer orders, billing details, order status, and menu items. This is
which,
dynamically generated, ma'am, by users.
sorry,
It is dynamically, it is generated dynamically, ma'am.
to Firebase.
Ma'am?
Which database you have used? Firebase
No, ma'am. Dynamic database.
at the real
Dynamically,
time.
ma'am.
At real time.
At real time, ma'am.
So what did you basically do in for that, for collecting the real time database? What technique you have adopted?
Ma'am, we use application load balancer, ma'am. But in future we can use for ML based food recommendation, ma'am.
What are the related works you have not discussed that?
Ma'am, we
Relate-
mainly focused on cloud deployment, ma'am, microservices architecture, and we containerized in the Docker for independent deployment. I would like to share our project also, ma'am. 1 second. I would like to present. One second, ma'am. We containerized our services in cook service, order service, and billing service. Ma'am, is it visible?
Hmm.
Yes.
In this, we containerized, ma'am. Cook service, front, order, and billing, and front end also. And our output will be like this, ma'am. Home, order, kitchen, and billing. Here, first we should move to ordering, ma'am. We should order any item. Like first one is masala dosa. We should add to kitchen pipeline. After adding to kitchen, we should go for billing, ma'am. In billing pipeline, we should generate bill, ma'am. Here we order masala dosa. We should specify the cost. Bill is submitted and invoice is generated, ma'am, for this 40.
You are telling that you took the dynamic data, that means the real time data. So, can
But
you please?
in future scope we can add, ma'am. But we already given, ma'am, this one.
No, I couldn't understand actually
But,
the
but
data which.
ma'am, but it is not Kaggle data or CSV data, ma'am. We have already given this data. In
Where?
further future scope, we can add,
Where you have given this data?
ma'am.
No, I'm asking where the data is actually, where is the data? Which database you have used for that?
Application data, ma'am. We use application data.
Okay, that the Docker and the containers which you have been talking about.
Yeah, yes, ma'am.
So what the advantage you got from this?
We can reduce scalability, and we can increase efficiency. And we use cloud computing concept, ma'am. We can use as pay as we go without any risk. It decreases the cost.
And what can be the limitations of your project?
Ma'am, limitations. We suppose we are using any traffic conditions, like during any festivals, we can use efficiently without any interruptions or lag.
That is the advantage part, no? Because it is everything, it has been interacting with the cloud.
And it has real-time tracking, ma'am. We can track our order from kitchen to table with live updates. And mainly easy billing.
Like if we the all other these food sites, if we talk about Zomato and the Swiggy and all, they are all built on this concept only.
No, ma'am. We are using microservices. Most of those websites uses monolithic.
They are server based.
In for monolithic structure, it has only one code base, ma'am. One code base, and we should deploy entire. Suppose we have mistake in we got any errors or bugs in front end, we should deploy whole project again for both front end and back end. But in microservices, we can deploy the any specific part. Suppose we have mistakes or any errors or bugs in only front end, we can deploy only front end part.
We need to deploy only front end part.
Front end part. So we divided microservices as 3: order, billing, and kitchen pipeline.
The language which you used for the front end is
React and HTML CSS, ma'am.
okay. What an idea! Nice one.
Okay, ma'am.
May I know the references part? You have not written any references.
Ma'am,
The references slide.
reference slide. No, I didn't mention any reference slide, ma'am.
Thank you, Mr. Ambati Mallikarjun, for that excellent and well-structured presentation. We are now open for questions from the session chairs or the audience, if any.
Yeah, okay, ma'am. Is there any doubts or can I ask any queries regarding the project?
Okay, so if there are no further questions, we shall now proceed to our next paper. Mallikarjun, sir, you can stop sharing your screen now.
Okay. Okay, ma'am. Thank you. Thank you, sir. Thank you, ma'am.
Okay, thank you.
Mr. Amit Nagarkoti, sir, are you there?
Yes, ma'am.
Okay, so now I would like to invite our second presenter for the day, presenting the paper titled Machine Learning Assisted Techniques for Enhancing Interpretability in Models under the code 427. I request Mr. Amit Nagarkoti to kindly take the virtual stage and begin their presentation. Over to you, sir.
Yeah, thank you, ma'am. Please let me know when you are able to see my screen.
Sure, sir. Yes, sir, your screen is visible.
Yeah, thank you. So, good evening to all and everyone. My name is Amit Nagarkoti, and I'm a tech student in Uttaranchal University. And my research title is Machine Learning Assisted Techniques for Enhancing Interpretability in Models. So here it goes. As we all know, machine learning models are widely used in almost every sector nowadays and are very helpful, but we cannot easily understand how they make decisions, as there is no transparency means how the result is being executed. So in sectors like healthcare, finance, or any customer analytics, understanding the prediction is very important. Means how we are getting the result. That is very important. That's when explainable AI helps to make these machine learning models transparent and trustworthy. Which means explainable AI gives the reasons, tells us the reason how the result is being classified. So, and in this research, we have used techniques like shape and lime to explain the prediction of the models, and which generally help to improve understanding and maintaining the good accuracy. And in the literature, from the literature reviews, uh, I have the study shows that simple models are easy to explain, but they may give their accuracy is generally lower. And on the other hand, complex models give accuracy, but they act like black boxes. Means uh, we cannot get the reasons why they are, how they can predict, and which features are more important for the predictions. So that's where the techniques like explainable AI techniques like shape and line are used. Means basically shape technique. It calculates which features are most important for providing the result, and lime which explains prediction for each individual cases. Means how result is differing for each individual case. And previous studies mostly used only one of these techniques separately, not together. And our work over here is to combine these techniques into one explainable AI framework. Basically, means our objective is to build a pipeline for customer churn prediction, which can be explained. Means we can justify the predicted outcome from the machine learning models. And we have compared logistic regression and random forest models, and then applied shape and lime techniques for the explanation. As you can see, this is the text stack which I have used on the screen. And uh, we have used a publicly available banking churn dataset, which contains multiple informations like demographic and also account information like age, credit score, their salary, and like that. We have handled missing values and encoded categorical features in numerical form. We trained logistic regression as interpretable model and random forest as high performance model, because as we know, logistic regression calculates the probability 0 and 1, which is easy to understand how the result is coming. And for random forest finds the complex patterns by going through multiple decision trees. So it is more accurate, but not that much explainable. Uh, so we have evaluated the model based on accuracy, precision, recall, these scores. And for the explainability framework, we have used shape and lime, which I have already uh, defined. So when we from the report we get the result that the random forest have higher accuracy, means it have accuracy of 86, and in logistic regression model we got the accuracy of 79, basically 7.99, which is 80. Logistic regression have uh, okay, sorry. So these are the accuracy of both the models. And we have also used unsupervised models. Uh, we have also used these unsupervised model clustering scores, which indicate well-defined and meaningful customer grouping. So these are the shape and line plots. Means in on the left hand side, you can see that uh, the features which are more important have higher shape value. Means for predicting the outcome, those features which are more important, they have higher positive values. And in on the right side, you can see the plot which explains prediction of single customers. Means they lime is basically used for a single entity. Means how the result is affecting that, how the result is coming for that single entity. And the positive value shows factor which are increasing the churn risk of the data set, and the negative values reduce the probability of churn data set. Means the higher the value, they have more the risk of exiting the data set. And this is the comparison plot of both random forest and logistic regression. As we can see, the value of random forest is above 0.8, and the logistic regression is between 0.8, which shows that both the models are almost similar in accuracy. And for the conclusion, the research what we have done is, and in the conclusion, by we have combined both logistic and random forest, which uh, which help us to predict the accuracy, and also help us to interpret the models. Uh, so this is the our research, which is based on explainable AI, and future work is uh, can be focused on by using a large data set or applying these techniques to not only to the banking data set, but also in other sectors like healthcare and real-time business decisions. And these are the references. Thank you.
Thank you so much, Mr. Amit Nagarkoti, for your insightful and well articulated presentation. We are now open for questions from the session chair or the audience, if any.
Sir, I want to ask one question.
Yeah, yes, ma'am.
Actually, why you have chosen explainable AI to complete your this the concept you have given for the explainable AI? Why only explainable AI is being taken to solve your problem?
Means explainable AI. As we all know, that means this is the new field where we can get. Means we don't know in machine learning models, we don't know how the results are obtaining. Means we don't know which factors are affecting us. For example, in any healthcare system, if any machine learning model is predicting any disease by seeing any scan report, so uh, currently we have doctors to verify that the result is correct or not. Means how accurate is the result. By using the uh, using explainable AI, we can get the reasons. Means which factors are affecting most to the result. Means it explains, means why a model can be trusted more. I mean how reliable it is, if we know the reason behind how the result is coming.
Can you please explain me like what exactly this shape and lime is doing in your problem?
Yeah, sure. I mean, shape is basically as we have collected the data, the shape is basically categorizing all the features like age, the banking, age and the salary, and how the tenure is. So means which will affect in means how shape is basically providing a value to each and every feature, means which is more important for the prediction of the model, means which factors are most important. And lime basically analyzes the results for each individual cases. It means if there are person A, B, C, they have wait, let me show you the, yeah. So in this right side, means this is for a single customer, the right side line graph. So if any person have low credit score, so the probability of exiting of that customer is likely more. Or if the age of the person is more, so the probability of exiting of that customer is likely more. Means it is comparing all features for a single entity. That is line. Means it is explaining why the person A have probability more for exiting.
Okay. Got an idea, sir?
Yes, ma'am.
Yeah. I
Okay.
got an idea what actually you want to say.
Yeah.
That's a wonderful thing. It's a
Thank you.
new, yeah, explainable AI is itself very advantageous.
Mm.
Thank you so much, sir. You may now stop your screen sharing.
Yeah, thank you.
Thank you.
Now we shall now proceed to our next paper. I would like to invite our third presenter for the day, presenting the paper titled A Systematic Review of Deep Learning Based Plant Disease Dissection Using GAN-Driven Data Augmentation under the code 430. I now request Ms. Anamika Singh to kindly take the virtual stage and begin their presentation. Over to you.
Yes, good afternoon, everyone. I'm just sharing my screen. Is it visible to all of you?
Yes, it's visible.
Okay. So, good afternoon, everyone. I'm Anamika Singh. I'm pleased to present our paper titled A Systematic Review of Deep Learning-Based Plant Disease Detection Using GAN-Driven Data Augmentation, which has been submitted under paper ID 430. This work has carried out under the guidance of Dr. Sharmila and Rathore, whose valuable insights and supports has been instrumental throughout the studies. The abstract part, basically overall surveys based on this. This study focused on the importance of early detection of plant disease, which play a critical role in precision agriculture. Basically, it is providing the improvement in crop productivity and ensuring food security. Traditionally, the plant disease identification, basically they are based on the manual inspection, and which include the labor intensive, then time consuming is also there, and highly prone to the errors, especially under varying environmental and climate condition. So with recent advancement in artificial intelligence, basically with the machine learning and deep learning and the power of augmentation, image-based plant disease detection has been effective in this field. To address this challenge, the generative adversarial network, that is GAN, has emerged as a powerful data augmentation technique. Basically, GAN can generate realistic synthetic plant disease image, which will improve model training, robustness, and generalization performance also. The next part is introduction. So agriculture is very important for the economic growth and for human being also livelihood. So here significant crop yield losses because of due to the plant disease, pest inspections, and climate condition also, varying in the climate condition. So according to the studies that more than 30% of global crop loss violate of inaccurate detection in the plant disease. And this is not only reduce the yield, but also lead to the excessive pesticide uses also. So basically, traditional plant disease detection, if you can see, previously it is like manual based field inspection, where the farmers are going to be the agriculture experts. Okay, but there are also certain types of limitation is there. The limitations are like they are very time consuming, labor intensive, and prone to the human error also. So this is one of the problem which we are facing. With recent advancement of artificial intelligence, that is nothing but the including of machine learning and deep learning, which we are part of as an advancement part for this problems as an effective solution. The responsible factors which are actually we can see the problem or the for the plant disease. If you can see on the slide, they are categorized basically in the three categories: fungal, viral, and bacterial disease infections. So fungal disease commonly include conditions such as scrap, rust, and scorch. Just a minute. And if you can see, the viral disease basically cause symptoms like mosaic patterns, leaf curls, embryons. And bacterial disease, basically, it is based on the bacterial spots, welling. I'm just focusing on the leaf of the plant. So the related, this fungal disease, viral disease, and bacterial disease, how it can be impact to the leaf of the plant and how it can be arise. That is also there. So on the right side of the table, summarize the review taxonomy, which is linking the pathogen types. Basically, symptoms include infected plant leaves. So here, viral infections basically categorized in stunt growth, leaf distortions, mosaic patterns, and deformation of the plant spot. And fungal infections basically overgrowth, roll, mold formation, leaf spots under the different you can say under the different leaf that you can see here, tobacco leaf, then cucumber leaf and potato leaf is infected with the viruses, and the rice leaf, wheat leaf, these are also infected with the fungi. This is the symptoms which they are getting on the leaf through this pathogens. And bacterial result in wilting, then water soak, lesion and rot, gall formation, etc. If you can see the tomato leaf, rice leaf, these are the example that is given through this pathogen, how they are infected. So now, basically, roles of the artificial intelligence, and basically in that also the GAN, it is called emerged as an effective solution to several key challenges with the support of deep learning in the agriculture application. One of the primary advantage of this data scarcity. Basically, the problem is related to class imbalance in the agriculture. So GAN helps in reducing the class imbalance by generating the high quality synthetic image for unrepresented data, disease classes. So different types of GANs, as you can see on the slide, that we can use in the agriculture research, that is DC GAN, which is effective for generating the realistic plant disease images. Cyclic GAN, which is for image-to-image translation task, and the conditional GAN, which is very effective, which allow the controlled image generated based on the class labeled. And there is a style GAN also, which is used to produce the high resolutions and the visual diverse images. So here, the GAN approaches basically shows the successful application across the various domains, basically in the precision agriculture, which include the plant disease detection, crop classification, then plant phenotyping, then other data-driven agriculture monitoring task also. If it is possible with the help of GAN, then The relative works, the literature review, if you can see, I have included the total 28 papers, which is basically focused on GAN, the gaps which are taken through the new technology and based on the accuracy result. What are the limitations area is there, that is also included. So basically this slide summarizes the key findings from the literature related to plant disease detection using machine learning, deep learning and GAN approaches. So here with basically mainly focus on the biological analysis of the plant disease, highlighting total 30% of crop losses which is caused, lost due to the pathogens and highly pesticide also. So here, with the advancement of the deep learning, studies introduce the CNN-based model for plant disease detection, which gives the accuracy between the 95% to the 99% under control situation. This is given with this, and despite of this promising result, they mainly reported significant limitation also, that is related to the dependence on the large data sets, then sensitivity to eliminations, background environmental variations, then limited to real field validations, and high computational complexity is also included as a limitation part of this, that is a research gap. From this, we got the problem statement that early and accurate detection of the plant disease is very critical for crop productivity basically, and for the sustainable agriculture too. So most disease identification practices basically based on the manual inspection. So we have to overcome with the limitation of manual inspection. We came to the new technology, that is machine learning, but they're also having some gaps related to the data, again the real-time data.
Ma'am, I request you to kindly wrap up in 2 minutes.
Okay, so the problem statement is like how the limitation is the manual, in the manual that prone to the human error. So we have to come with the AI effective solution, basically with the deep learning and the GAN. So this is a problem statement. Basically, machine learning roles in the AI detection is like they are having different technologies, as you can see on the slide, that is SVM, k-nearest, RF, decision tree. They have already used and they had given the good result, but that is not enough for a certain kind like class imbalance or a saturity. So these are some model descriptions that already we have seen for the machine learning description and their accuracy also. If you can compare with the deep learning models, so deep learning models here, which we are going to use, this is a deep learning, basically the limitation which is present in the machine learning. To overcome this deep learning processes there, in that also the custom CNN model for the crop specific disease detection, this architecture is given, where we have to deal with the real-time data set, and it will go for different technology like YOLO, and they are going to be data pre-processing is there. Then after pre-processing, then specific data is going to be collected and it is going to be processed with the training set and data set. That is also is here in this architecture, basically test data set, training data set, how they are going to be combined and they can give the good performance assessment also. So these are some CNN based models which are the part of deep learning and their accuracy is given. And then we have compared both ML and DL models. So we found out that DL model is having good result as compared to ML model, but only when it is going to be combined with the GAN. So if you can see the ranking of this performance ranking, YOLO with GAN is 99%. That is the highest ranking. And you can see the further technique mobile P82, that is 98%, decision that is 97, P9 for 92, and XPOS. This is a comparison of ML versus there. So in conclusion, I want to say that for disease detection, if we can deal with the there are total 178 studies there. In that also the GAN specific, I have done 28 studies, and in that GAN is a very good for disease identification and for good growth of the what we can say the yield productivity. And these are the references which I had used. Yes, thank you.
Thank you, Ms. Anamika Singh, for a comprehensive and well-structured presentation. We are now open for questions from session chair or the audience, if any. So if there are no further questions, we shall now proceed to our next paper. I would like to invite our fourth presenter for the day, presenting the paper titled Phishing URLs Detection by Character Level Encoding using Contrastive Pre-Training and Supervised Classification under the code 440. I invite Mr. Ayush Kumar to kindly take the virtual stage and begin their presentation. I request you to kindly present in 7 to 8 minutes. Over to you, sir.
Good afternoon, everyone. Am I audible?
Yes, sir, you're audible. So you can start sharing the screen.
Yeah, 1 second. Is my screen visible?
Sir, can you switch on your camera?
1 second. Am I visible?
Yes, sir. You may begin the presentation.
Thank you, ma'am. Good afternoon, everyone. My name is Ayush Kumar, currently pursuing MTech from Graphic Era Deemed to be University. Today, I am very enlightened towards to present my topic of phishing URLs detection by character level encoding and supervised classification. Now moving, I will be briefing towards the introduction, methodology, tools and techniques, and result analysis of my research work. As we, in the modern security system, the detection of malicious URL becomes the critical component and increasing the rate of phishing attacks. The supervised learning has classified the phishing URLs would need to extensive volumes of label data, which can be costly and time intensive to acquire, as the domain of each and every URL are being are being are being not able to retrieve, as the domains will be changing will be changing as sorry for my inconvenience. I'm a little nervous. Um, the domains are being changing, which attackers use to phish us, and the user will be loot for us. My paper presents a self-supervised learning model that uses SimCLR paradigm to constructive learning to train strong URL representation without the need to use manual labels. Also, the argument URLs uses contrastive loss to pertain with a convolution neural network for character level encoding. Moving forward, why we need it? The phishing attack has increasing exploits subtle structure manipulations in URLs to deceive users and bypass traditional detection systems, which required a manual and a human force as a supervised learning. So I developed a fully self-supervised learning model, which is very reliable, which I will be concluding it further with my accuracies and all. There is there are multiple things that we need for robust phishing detection framework, that is learning meaningful character level URL representations without heavy dependence on label data, capture structural variations and encryption techniques commonly used in phishing URLs, achieve high classification performance even when only a limited amount of label data is available. Moving forward towards the introduction, what is phishing and why and what are we doing it? Phishing is just a fast-evolving cyber threat that disguises malicious URLs as legitimate ones to exploit users' trust. Attackers use normally character replacement, fake subdomains, or token insertion, which reduces the traditional models and which fails the traditional models to detect the phishing sites. Uh, I have done pre-training. I have taken a pre-trained model and XGBoost classifier, and which is fine-tuned by me with a labeled dataset, which is limited towards me, which improves accuracy, robustness, and generalization. Now, coming forward toward the methodology, Firstly, the URL augment strategy, which generalize the URLs pairs using domain-specific transformation to simulate phishing manipulations. Next is character level representation. In XGBoost, we have an encoder and a decoder. The encoder provides the phishing URLs like the hackers used to get to lure the users. A CNN-based feature extraction, which is used to extract features with 1D convolution, pooling, and projection layers to produce compact feature representations. The embedding normalization I have applied L2 normalization, that is Euclidean distance, to ensure unit length vector suitable for cosine similarity. XGBoost classification, which I've already discussed, to classify phishing and vanished URLs. The embedding I use the TSNE to visualize the clustering and separately between phishing and winning URLs. Now, moving deeper towards the methodology, I would like to discuss URL argument strategy. In the argument strategy is basically based on image spread, but the URLs does not have any image or something with techniques like rotations or cropping. So we need to specify. So we need to do some transformations to design it. So in this, the transformations are random character drop, in which the alphanumeric characters used to simulate noise, in which if there is a domain like Google, then Google can be like GOOL is the spelling, but GOLE can also be there as a hacker if I am luring some user. The token swap permutates are separated by only by a dot. Subdomain shuffles that reorder subdomain components. Protocol flip like from HTTP to HTTPS or vice versa. A slash, like in the URL, we have a path also. We can lure it by adding a specific path, which can be a very fishy. Also, TLD synonym replacement, which replaces the domains like .com, .net, or .org with similar alternatives. Now, here is the algorithm which I am using, in which the these are the transformations which I have used in the algorithm. I have discussed this in just previous slide. Now, moving forward towards the character level encoder, the embedding layer maps the character ID towards dense vectors as the machine understands only numeric values. Now, 1D convolution layer extracts the n-gram like lexical patterns, adapting max pooling, fully connected projection layer, and L2 normalization. The resulting outputs are 128-dimensional embedding for each URL. Here is something I want to have a look. The anti-extend loss, which is used with the encoder and decoder architecture for this specifically, in which we have to calculate the negative similarity as well as the positive similarity for the anti-extend loss function, because the encoder and decoder only on the similarity weighted, but it is not able to and what type of is it positive or is it negative. So on the basis of that, I want to just to be more as a kind of accurate, so I calculated it both and used the anti-extend loss function. Now, here's the literature video. These are some references which are not the references which I have. These are the researches that has been done before, and I've studied it over there, so that I have a very hands-on experiences on this before building the project. The tools and techniques which I have been used is the Jupyter Notebook, the Colab, the main language is Python, and the library is TensorFlow and Pato, which is mainly known for ML and DL based, Pandas and NumPy for data cleaning, scikit-learn for inbuilt pre-trained models use, and Matplotlib and Seaborn for visualization. The techniques are data pre-processing, feature extraction, embedding, and model training and evaluation metrics. Here is the result analysis. The XGBoost confusion metrics have a phishing. Here you can see they've been visualized as a from Beijing is 3019 and 181 from the desired data set. And phishing one is 119 in Beijing and phishing 3001. The evaluation parameter which I was discussing earlier, I have achieved the accuracy of 94% and the precision of 94. The recall ratio is 93, and the F1 score, which is combined of precision recall, is 94%. Moving towards the second level, these are the references these are the previous models which are built by professionals attaining the accuracy, and my proposed model have uh, get good accuracy among them, as you can see it. Now, these are the references which I have taken help from it. As being a part of the project, I am very enlightened towards this, and thank you.
Thank you, Mr. Ayush Kumar, for your detailed and insightful presentation. We are now open for questions from the session chairs or the audience, if any. Okay, if there are no further questions, we shall now proceed
Excuse
to
me,
our
ma'am.
next. Yes.
Excuse me, ma'am. There is a thing. There is a clash between a second presentation of mine, which is being in this slot only. But I have talked to with Dr. Vijay sir, which they said if I am able to give it in this meeting only, so can I give it right now, right away? There another presentation.
Okay, you can give.
Okay, thank you. Uh, Okay. Now my second presentation is leveraging assemble learning for predictive modeling of music popularity. Now, the same format I want to follow: the introduction, the methodology, the literature review, tools, and result. As we all know, music has become a very important part of our life, and and the online platform streaming like Spotify, Apple Music, and many more had immersed this in a very good format and very easy to use it. The music industry is so vast that has over 1 lakh songs, or even I would say 1 million songs, which are released. Now, to have a growth in terms of popularity, the assignment of the features of the song is required. Um, my studies focuses on using assemble learning techniques like random forest, XGBoost, or stacking of linear age regression, and hybrid assemble of SVM. Now, moving forwards, what is the problem? The predicting of music popularity accurately is challenging due to complex and non-linear relationship audio features like energy, danceability, loudness, and tempo. The energy is like if we are listening towards electronic music, which have a very great bass and all. So it will be energize us with the adrenaline. The danceability, the in which the shows, the concerts, or even in the marriages we dance to it, is also a factor. The loudness is covered in electronic only. Now, the traditional single machine learning models often fail to capture intricate features and interactions, leading to limited predictive performance. The data set which I am using contains a high dimensional features and potentially multipolarity, which may reduce model efficiency and generalization capability. The problem is to design and evaluate an optimized assemble-based regression model capable of accurately predicting the song popularity using Spotify audio features. Now, the introduction part. The online, as we all know, the online music streaming has rapidly evolved in 1999, the Napster era, which was the first era, with platforms like Spotify, Apple Music, and YouTube Music dominating over 50% of the market. With millions of songs produced annually, there is a growing need for efficient prediction of song popularity. The study predicts that popularity using assemble learning based on audio features such as danceability, energy, and loudness, tempo, key, and mode, which I've already described earlier. The data set which I have collected is from Kaggle, which and enhanced using multivariate Gaussian data augmentation to improve diversity and handle imbalance. The target PSA was applied for dimensionality reduction, extracting 5 principal components while retaining maximum variance and reducing overfitting. The dataset was split into 80% training and 20% testing to attain a higher accuracy as training. In training, the model will be able to learn more of a patterns, and 20% is of testing what all we can have to go further. Now, moving on towards the methodology, I have just discussed about the data collection. The data set is I have taken from Kaggle, which has around over 18,045 songs. The data pre-processing, the missing values were removed, and the feature engineering was performed. The dance vector can be equal to energy into danceability, which I have added on to it. Multi-Gaussian data augmentation increased dataset size, which is a very good factor, as there is a limited data in the Kaggle, and I have to take it in manually. So the Gaussian data augmentation have helped me a lot in this. The exploratory data analysis, the histogram, box plots, and correlation heat maps help you to visualize this. The assembled training model have random forest regression. The model evaluation was assessed using MA, MSc, and R-square to measure the prediction error and explanatory power. The data collection, the original data set was contains song popularity, song duration MS, accountness, danceability, energy, instrument, and key. Data pre-processing, the data pre-processing was first cleaned by checking and removing missing values. As discussed, multivariance Gaussian data augmentation was applied to expand the dataset, increasing the dataset over to 37,000 rows. The principal component analysis reduced the dataset to 5 major components while retaining maximum variance. Now, moving towards the data analysis, the EDA was performed on both original dataset and the PCA transformed dataset to understand patterns and trends. In the original dataset, the EDA was focused on analyzing feature distribution, relationship between variables, and correlation with the target variable. After applying PCA, the histograms and the visualization were used to analyze the relationship between principal components and their variance contribution. Now towards the training and testing, as discussed earlier, 80% training and 20% testing, it has been stated. Random forest tagging, the hyperparameter were optimized using random search CV with threefold cross-validation. The model used 300 estimators, max F of 30. Execute boosting, in which the optimal configuration was 100 estimator, max F of 10. Stacking, linear regression, and Rich were used as base learners with Rich as the meta-aggressor. Hybrid SVM support, the support regression model is linear, polynomial, and RBGF kernels were trained. Finally, the random forest meta border was trained over 500 estimation, max up of 20. Now these are the literature review which I have been read for presenting before presenting this presentation and working on this project. The tools which have been used is like the previous one, the Jupyter Notebook, the Google Colab. Main language, only preferred language is Python. TensorFlow, PyTorch for ML models. Pandas and NumPy for data cleaning. Scikit-learn for pre-trained models. Matplotlib and Seaborn for visualization. The techniques which were evolved in was feature engineering, multivariate Gaussian data augmentation, and PCA. Now here are the result analysis. In the first image, there is a linear regression which we have, which have plot a thin line between the actual data and the predictive values. The second feature, the second image is of the models which have been used. What has the highest impact on the predictions which are made by our models? Here are the performance indicators with and without the PCA. With the mean square error of 216, which was reduced to 96, and the mean absolute error was reduced to 6. The R-squared value has been just increased, but it doesn't matter because it's very less. Now the reference which I have been used from the past professionals have the MSc of this. And future work
Sir,
in
I
this.
request you to kindly conclude in 1 minute due to shortage of time.
Okay. The future work, the study can be expected using other internal factors like music genre, the mood of song with audio features, and the categories of the song can be divided into happy, sad, party, or relaxed. Moreover, the framework can also expand to evaluate songs that are popular in other languages. These are the references which I have taken help from it to build this project. Thank you.
Thank you, Mr. Ayush Kumar, for your insightful presentation. We are now open for questions from the session chair. Okay, so now I would like, ma'am, you can ask now.
So may I know the references slide, sir? I need to see your references slide. 2018, 23, 14, this is 20, which is this. So you have not taken any recent paper, like the 23, 24, 25?
Ma'am, I would have taken it, but I would like to go deeper in it. So I would not recommend myself to go into such a recent thing, because it's like music is all over around us, and I also listen and you also listen. So I would like to go deeper in it, as I have I'm a good music listener.
That is okay, but when we move forward, so many things come in the old study. People used to combine it with the new trends. So actually, if you have been going with your topic, so many other people have been come up with the same concept. So of course, like it is usually said, like whenever we submit in the SCIs or scoopers and all, so usually they say that you have to give the references for the last 5 years. They give more weightage to that. As far as I know this thing. I don't know, but like your guide has also taken this consideration. But at least 2 or 3 papers should be from the last 5 years.
Okay, ma'am. Next time I will be making sure to at least read it and get the reference from it. Like you said, it's like a music trend changes. So I will be next time I will be focusing on the recent papers only.
Yeah.
Thank you, ma'am.
Okay.
Now
Thank
I
you.
would like to invite our fifth presenter for the day, presenting the paper titled Remix FND, a multimodal domain invariant framework with adaptive evidence retrieval for cross-domain fake news detection under the code 443. I now invite Mr. Priyadarshan Khadtale to kindly take the virtual stage and begin their presentation. Over to you.
Okay. Thank you so much. I'll share my screen.
Sir, I request you to kindly complete the presentation in 7 to 8 minutes. You may turn on your camera also.
Sure, ma'am. Ma'am, will it be okay if I keep my camera on because I'm on mobile network?
Okay, it's no problem.
Okay. Okay. Thank you so much, ma'am. Good afternoon, all the presenters and presentee over here. So myself, Priyadarshan Khadtale. I am currently ME student in Thakur College of Engineering and Technology. Today, I will be presenting a paper called Remix FND, a multimodal framework for cross-domain fake news detection under the paper ID 443. So moving ahead, I would be starting with the challenges that all the current or existing systems have. So as of now, whenever a fake news comes in, we have certain domains like political, entertainment, and etc. So when a cross-domain news comes, there is a drop of 12 to 19% about the accuracy. The current system is very slow. As per the trends, it should be like within like 100 to 200 milliseconds. But currently, it's far more than not explainable. So currently, whatever the news we get, or we are able to detect whether it is a fake or like the real news. We don't know whether the like how this particular news is fake, or uh, what are the factors that needs to be considered. Okay, and vulnerable. So there are many uses that are paraphrased by the AI systems nowadays. So all these problems are not solved in a single system or a single software. So that's why we came up with the new innovative way. So what is this paper about? So we have tried to like innovate uh, certain certain technologies, combining them together. So very first is domain invariant meta learning, which work across the different data sets. Smart routing, smart evidence retrieval is like we will have the fact checking mechanism in place that would give us a confidence score. Based on that, the problem of slow responses or slow detection can be resolved. Also, we have a few assembler detection that detects the strengths for each complementary fact news. So original method, and this is the state of art in 2026. So here you can see we have multi-step evidence retrieval, which have a good strength with a accuracy of 91%. But only weakness it have is it's slow to response. Multi-domain visual information, it's fast, but it's like sort of overfitted. So once information is altered, we get some missing data. Dual dual addressal devising. So it is not it is able to adopt the domain. So when a news is linked with multiple domains, it tries to give us some accurate data, but only we have only 76% of success rate there. LLM detects. So whenever a content is or a news is generated via the AI, there are some systems in place that are able to detect such paraphrase. Moving on to our solutions, so we have combined these three technologies in place. So domain invariant meta learning, guided routing, and explainable assemblers. So regarding the DIML, will we train a domain that tries to guess which domain data comes from. The feature extractor learns to fool the discriminator. We also have a meta learning in place that tries to optimize the starting point for the model, which can quickly adapt to a new domain. Uh, so And next we have the uncertainty. So not every article needs the similar sort of depth. That means we don't need to actually examine the actual like in depth if we know the confidence earlier. So what happens when an article comes in, there are certain paraphrasing and certain paragraphs which we know that based on the facts that particular data is correct or wrong. And if we have a score of 70%, we can show a high confidence, and instead of doing actual computation over there, we can reroute it to like to a like as an actual passing for the fake news. So that's how we can reduce some response time. Third one is explainable assembler. So then we have multiple points of failures, and to detect that, we have detectors in place. So whenever certain certain articles or news are generated by any AI system, they tend to leave behind certain digital footprints such as watermark, murals, zero shot, and retrievals. We also have some fingerprints. That is the digital fingerprints. We know that uh, certain amount of data has been generated via the AI system. So that's how we are trying to detect how the news is created, whether it's true or false. Second is the system architecture. So multimodal extraction from the text, image, social context, attention-based fusion are being used. And for uncertainty based, again, we have the confidence. We skip certain part of articles to for faster responses. Uh, Again, the uh, detection, a similar detection and explanation. So we have that weighted detectors that can help us to give the uh, that can help us explain whether the article is from the AI or any system generated. And that's how we get a final prediction. Now, evaluation of benchmarks. So I have used 6 data sets across multiple domains, PolitiFact, Gossip Cop, Co-ed, Fever, adversarial, cross-domain. So these data sets are from different domains. Now each data sets give us a good understanding of how the articles are related with each other. With this system architecture, we were able to see a good improvement in accuracy, 93.8%. The original was 91%.
Sir, 1 minute left. Kindly wrap up in 1 minute.
Sure, ma'am. Okay. So also from cross domain, we have seen a good percentage in improvement, that is 9.1%. We were able to make the response faster, 83% faster. All the baselines were interpretable. We have a like good robust system. Okay, these are certain benchmarkings with the current system that we have in place. So as you can see, against the DAL, UMD, M-user, we have good uh, percentage of improvement, that is 93%. And again, the cross-domain performance, we were able to see 85% improvement, and again, a drop of 8.4%. So that's what we have achieved in the all the targeted areas. Regarding the future and scope, so we are planning to integrate it with the social media, news verification tool for journalists, automated content moderation. Future scope, we can use it for like multilingual support. We can use videos for deepfake detection. We can also continuously learn about new emergent tactics and integrate those as well, and reduce the dependency of fact-checking databases. Thank you so much.
May I come on the third last slide, sir?
This, this one.
Yeah. Okay. Okay. So, what do you understand by the term, sir? Accuracy and F1 score. Difference between them?
So accuracy means whether the news or the article provided is accurate or not. So how does the system interpret its like with the it's like text detection, and some of the texts are they check for grammatical mistakes and punctuations. So we have certain things in place, like uh, many people use rage baiting and click baiting. So they encourage us to click on uh, such links and data. And when we click that, we get to know that this particular thing is incorrect. So that's what the accuracy means. And F1 score is like the machine learning metric for precision and recall.
Yeah. And for the cross domains,
Cross domain means like the multiple domain. So in our case, we use the political, entertainment, and healthcare domains. So those domains can be like used for the retrieval of data. Uh, so we already have this DAL and M user that used to do such cross-domain verification.
yeah. And can you please tell me about the sensitivity and specificity?
Like
Through which
in
we can we need to through which we actually calculate the F1 score, the sensitivity of your findings and the specificity.
okay, so ma'am, uh, I actually use a model. There was a Monte Carlo method. That's how I used to calculate that.
Mm-hmm. Okay. Actually, that precision and recall which you called, these are the another terms for the sensitivity and specificity, sir. This is the same thing actually. When we talk in terms of the medical applications, whenever like more the precision and recall have been taken in this regard.
Okay, ma'am.
Yeah, that's the same thing through which we can calculate the F1 score.
Okay.
That's okay, sir. Thank you.
Thank you so much.
Thank you, Mr. Priyadarshan Khattale, for that insightful presentation. Now, I would like to invite Dr. Shree Sharma to present her paper. Are you there, ma'am? Dr. Shree Sharma, ma'am, are you there? We shall wait for
you. It seems that ma'am is connected here.
Yes, ma'am. We shall wait for 2 minutes. I think she is not there. So, with that, we conclude today's paper presentation session at UNI-TEAS. We sincerely thank all our presenters for their valuable contributions and our audience for their active participation. A special thanks to our session chair, Dr. Dhiren Patel sir, Dr. Priyanka Mishra ma'am, for guiding the discussions
Yes, ma'am. Hello.
with
Hello, are you audible?
clarity and depth. I would request
Hello.
would now request all participants to kindly switch.
Yeah, I think
Hello.
this is today's session
Yes, sir,
is
we were just
completed now.
concluding of the session.
Yeah. Hello.
Hello. Yes, sir, you're audible now.
Yeah. Yeah. So today our session is completed, and thanks for presenting all the participants, and we appreciate your efforts.
Thank you, sir.
Okay. Thank you. Thank you.
Yes, sir. I would now request all participants present to kindly switch on their cameras as we take a virtual photograph to capture this memorable session. Thank you
Okay. Now we conclude this session.
all, and we look forward to seeing you in the next session. Have a great day.